All right, so we've already gone over the properties for our series, but these are ones for convergent series. So if our a sub n and b sub n are both convergent series, then these are what we get. So it makes sense that we could add them or subtract them, or if there's a common factor, we could just factor it out. It's like this. We have our two series here, one's in green, one's in red, and this is one we're going to look at. And so if you think about adding the green and the red together, they would just make the black since they both converge. So it's like this. As they move through here, this is the green, this is the red, and that's the black. And you can see it's just this one plus this one is equal to that one. So the partial sums here plus this one would be this one. We're just adding up the sums as we go through them. So if they were both positive, we would add them. If one of them was negative, we would just subtract them. So since we know these two do converge, we've already done ones that are similar to them. One's a geometric, the other one we use partial fractions. We can do it this way. We know that one converges, so we can find out what it is. We know this one converges, so we can find out what it is, and then add them together to find out what they converge to. So what is our limit for both? So let's look at the first one, which is our geometric. And so we know it's geometric because it has that exponent with a ratio, so we can just rewrite it like this. And then just like before, we're looking for that n minus 1. So we would go 1 over e to the n minus 1. And now it's all set up, and so we say 1 times 1 over e, 1 minus 1 over e. So if you need the formula for that, you can look back at the infinite geometric series. We have this. So we get 1 over e times, and then it's 1 minus 1 over e, which would just become, so this would be e over e, so it's e minus 1 over e. And then we flip it. And we get 1 over, let's shrink it a bit, 1 over e minus 1. So that is our first one, little squiggly line. Now the next one is a partial fractions. And so we're going to look for that telescoping series to see if we can find out what it works. But first we need to have our partial sums. So I equals 1, we need our s sub n basically. And then this would be 1 over I plus 1. And then we use our partial fractions. So I'm going to write those off at the end. So we're going to have a over I plus b over I plus 1. And so this would be ai plus 1 and bi, which is ai plus a and bi. And we need these to add up to be 1. So a plus b is equal to 0 because there is no I here. None. So they can't add up to anything but 0. And a equals 1. So that would imply that b is negative 1. So we can rewrite this. And again, we're looking for that telescoping series. So we wanted to see that negative there so that we have our subtraction. So this would be 1 over I minus 1 over I plus 1. And then we plug in our numbers to see what we can find a pattern and then just convert it back. So first would be 1 over 1 minus 1 over 2. So that was if we plug in 1. That'd be 1 and 2. Plus, now we plug in 2 and we get 1 over 2 minus 1 over 3. And there it is. They're starting to cancel. Boom, boom. So it's already nice. Now we move on and it'd be 1 over 3 minus 1 over 4, dot, dot, dot. Let's move this down a bit like that. Perfect. Plus, and then we'd have n minus 1 minus 1 over n. So if I were to plug in now n minus 1 here, the one that's right before n, because that's what I'm going to do at the last. I want to see if things cancel correctly. If I plug n minus 1, I get n minus 1, and then the 1 would cancel, leaving me with just n. And then I would have 1 over n minus 1 over n plus 1. And it cancels perfectly. See, right there, boom, boom, which means that would have been canceled before, leaving us with the first and the last term. So this would become 1 over n minus, become 1, actually. 1 minus 1 over n plus 1. So now we got to take it to infinity. So limit as n approaches infinity of 1 minus 1 over n plus 1. And we know that goes to 0. And so we get 1. All right, now we just put them together. So our sum from n equals 1 to infinity of 1 over e to the n plus 1 over n plus 1 is equal to 1 e minus 1 plus 1. And so now all we have to do is add them. So 1 over e minus 1 plus e minus 1 over e minus 1. The 1's cancel, and we get e over e minus 1. And there we go. So if you can see that the individual series converge, and then we can apply these rules to it. We've already brought that number out before when we did power series as well. Or sorry, geometric series.